we can illustrate four-dimensional shapes. At first thought, this appears impossible. However, regardless of the limitations of our space and of our experiences, the number of spatial dimensions are not limited. Since we can illustrate a three-dimensional shape using a basically two-dimensional drawing, then it stands to reason that we can illustrate a four-dimensional shape using a three-dimensional model. The space we live in, as we can observe, has three spatial dimensions plus a dimension of time, where time is unique from the other spatial dimensions because, one, it is not interchangeable with the other dimensions, and two, we are constantly moving through time and in one direction. A way of determining the number of spatial dimensions a space or object or shape has is to see how many straight lines can be placed in it where each line is perpendicular to every other line. So, how can we develop an understanding of shapes that have four or more dimensions? Here are tools we can use. They work for me. We can set up a series where each figure has one more spatial dimension than the previous figure. As for what comes next, we can apply this series to shapes that follow specific rules. For example, a series based on a square, the two-dimensional shape is a square and the three-dimensional shape is a cube. Then we examine what is required to go from each figure in the series to the next, how the added dimension plays a role. We can also make a series of numbers of types of orders in each figure. By doing these things, we deduce rules for the series, increase our understanding of spatial dimensions, and deduce the next figure in the series. In a series based on a triangle, the 2D shape is a triangle and the 3D shape is a tetrahedron, which is a pyramid with a triangle base. Unique to this series is that each figure has the least number of borders needed to close a shape without any curved parts. Also, each corner is connected to every other corner by straight lines. Now to share some models I built out of toothpicks and glue. But one more explanation first. Just as drawings of a cube illustrated as viewed from different angles, so too three-dimensional models of a four-dimensional hypercube. Here's a cube as illustrated as viewed from three different angles. Next, I will show comparable views for illustrating the four-dimensional shapes. Note there are two different models for this first comparable view. Now here's a tetrahedron as illustrated from two different angles, all the corners being illustrated as red dots. Next, I will show comparable views for illustrating the 4D shapes. This one is a 5D shape based on the triangle. I also made a candy holder in the shape of a 4D shape in the series. And here's a 5D shape in this series as a candy holder or can serve as a Seder plate. Thank you for watching. If you found this interesting, please share and like.